A current carrying conductor in a magnetic field experiences a force, what a surprise, of F newtons. What will be the force on the conductor if its length and the current flowing through it are doubled? So you're changing the initial length to double the length, and you're changing the current to double the current. If we think about our equation for force, it looks something like F equals BIL sine theta. In this case, sine theta isn't changing, so we don't need to worry about it. And the magnetic field isn't changing, so we don't need to worry about it. Now we have force is proportional to current times length. So if we double the current, then the force will double, and if we double the length, then the force will double. That means if we double both of them, then the force will double twice, with the result of a force 4 times greater. So our correct answer is 4F. All right, next question. Question 10. A current carrying conductor in a magnetic field experiences a force of F newtons. What will be the force on the conductor if the magnetic field in which it is placed is halved in intensity? So once again, we can use F equals BIL sine theta. But this time we're not worrying about IL or sine theta, so we can just say that force is proportional to the magnetic field strength. Once we have this, it's pretty easy to see what happens when we halve the magnetic field intensity. The force will also halve. So the new force will be 0.5F. And we can see that that's the correct answer. Question 11. A current carrying conductor makes an angle of theta, well, that's a very specific angle, isn't it, with a magnetic field and experiences a force of F newtons. What will be the effect of the force on the conductor if the size of theta is increased? Now let's think about this for a little bit. We'll assume that here's the magnetic field, and here's the conductor at 90 degrees, and so theta is 90 degrees. And this will be the maximum force that we can get on the conductor. If we increase theta to, say, 100 degrees or 110 degrees, then the force will decrease. So that makes option C look pretty attractive. And it's definitely not option A. But hang on a moment, before we say that C is the right answer, what would happen if we started off with an angle less than 90 degrees? If here's our magnetic field and here's our conductor at that angle, then when we increase theta, we'll get closer to 90 degrees and the force will increase. So now B looks like an attractive answer. In fact, I'm sure that you can see from the options by now that the correct answer is not going to be either of these. It's going to be D. The question is unable to be answered unless we know further values. Specifically, we need to know whether theta is less than 90 degrees or more than 90 degrees, or exactly 90 degrees. A current carrying conductor in a magnetic field experiences a force of F newtons. What will be the force on the conductor if the current flowing is tripled, its length in the field is doubled, and the magnetic field in which it is placed is halved in intensity? So we're changing 3 different variables here. And if F equals BIL sine theta, and we can ignore the sine theta because it doesn't change, we can say F is proportional to BIL. Now, the length is doubled, the current flowing through it is tripled, and finally, the magnetic field in which it is placed is halved. So we take all these multipliers and we multiply them together. And it's fairly easy to see that the times 2 will cancel out the times a half. So we're left with times 3. That means the new force will be 3 times greater, and our answer is 3F. These sort of questions are pretty easy to do once you know how.